Do you know the regular expression started with POSIX? Do you know how to identify the basic and the enhanced regular expressions? Do you know which one of these is used in Python? Stay tuned till the end of the video to know all the answers. Hey guys, welcome back. In today's episode, we are going to discuss the below points. First, we will talk about a general introduction of what is regular expression, which is abbreviated as RE or RegEx. Next, we will talk about the basic regular expressions. Very next to it, we will talk about the extended or advanced regular expressions. And remember the name, the BRE and the ERE are the abbreviation for these two type of regular expressions. Now from birth, these two are different. So we will make you understand and educate you about these two, so that in case you see a regular expression, that means a code where the syntaxes of the regular expressions are used, you can identify whether it is a BRE or whether it is a ERE. Next, we will talk about in our Python which of these two are used. That means in Python whether we are using the BRE or the ERE. So that will make your mind clear which one to learn. Next, we will talk about the regular expression matching, and we will talk about the different syntaxes for range matching. Range means whether it could be a character range, it could be a numeric range, or it could be a alphanumeric range, or something in between. So we will talk about the range matching. Next, we will talk about the regular expression matching syntaxes for micro matching. That means we want to match each and every character or each and every numeric literals, all these things. So that means whether we want to match an alphabet or we want to match a number, and we are matching exactly as they are written. So in that case, we will be using the micro matching. So using these two, we will start our syntactical journey for the regular expression. And before that, anything we have is a very conceptual part. You can use chapters in case you know anything of this and you want to directly jump to any one of this. So that's the menu for today. And without any further delay, let's begin. The regex or RE, these are the abbreviation of the regular expressions. Let us see an introduction so that you have a basic familiarity with the regular expressions. Regular expressions, that is REs or regex, are a specialized programming language originated from POSIX. The POSIX is a basic operating system feature that exists in both case of the Windows and the Linux and the Unix and the Mac OS. So you can learn about it. If you want to go in depth, you have to search in the search engine and get the details. So you can understand that regular expression came from the very operating system features. POSIX is called Portable Operating System Interface, is a set of standards. So it is a standard. POSIX specifies common interfaces, APIs, and shell utilities. That means the POSIX allows some code or some instruction that could be made compatible with multiple operating systems which support POSIX. It ensures compatibility and portability among various operating systems. That is just we have talked about. Adhering to POSIX standards reduces the effort required for porting software or code. And this is why, apart from some few features or some few specific module, if you are using the basic Python code, you can use the code in Windows, you can use it in Linux or in the Mac OS or in the Mac OS. So it is portable, and that facility or that compatibility comes from the POSIX compatibility. The POSIX here is the full form. Already we have talked about. Basic regular expressions and extended regular expressions are the two types of syntax supported by POSIX. POSIX means at the operating system kernel level. These BRE and ERE are both supported. Now, these are something which came with the POSIX, and later on they were adopted by different programming languages like Perl, Python, Ruby, Java, etc. So the BRE and ERE came with POSIX, which came from the operating system itself, and it was created because of the software code portability from one operating system to another. You can see that any software that you are using today in desktop, I'm talking about desktop or laptop, in that case you find generally if there is a software, right, that is available for Windows, that is available for Linux, that is available for Mac OS these days, and that compatibility feature came from the POSIX standards. And we have the same thing for the regular expression. That means regular expression is not something that is exclusive for Python or Perl or something like that. It's a general feature that came from the very basic thing in an operating system. So I want to clear your mind before we jump into or dive into the regular expressions in Python. You might think that something is fascinating about the Python and the regular expressions are exclusive to Python. No, it's not like that. It is there with every advanced programming language nowadays, and Python has adopted that from the POSIX, and we can use our syntactical skills to write regular expressions for string matching, text matching. So we are done here. Let's move on to the next slide. Basic regular expressions. Here we talk about the basic regular expression that originated from the POSIX. BRE is a type of regular expression syntax used in various Unix utilities. Why we say Unix utilities, you will come to know, because these are things that when you learned Linux, you came across the sed and awk, right? In those binaries, some of them supports the regular expression, and I think BRE is there. We have an entire series on the bash programming where the sed and awk programmings are discussed. Please go ahead to the playlist and watch those episodes in case you are curious. It provides a basic set of pattern matching capabilities. So this is very beginning or primitive set of regular expressions which can be used for text matching. What do you understand by text matching? Now this is a very good question, right? So I want to match this word, right, the basic, with some programming instruction. When it reads the entire string, I have to check whether this particular word is there or not. So that is called the text matching and string matching, whatever you say, and that is the purpose of the regular expression. BRE uses a subset of regular expression syntax compared to extended regular expressions. That means BRE was first generated, then the ERE. That means ERE has a greater coverage and BRE has a lesser coverage, and hence the BRE is a subset. Now the first common BRE matching characters include star, question mark, set of brackets, this one, the caret, and the dollar. Okay. It does not support features like alteration, grouping with parentheses, and quantifiers like this one, the second bracket. So by now we know what are there and which it do not support. BRE treats meta characters literally, that means as they are, unless they are escaped with a backslash. That means what is a meta character, right? Backslash n, that is for the new line character, all these things. So BRE treats meta characters literally, that means they think that is a text as is until or unless that meta character, that means a backslash n, is preceded by another backslash. Until or unless like that you are writing, it will treat as a normal string. It is the default regular expression syntax utilities like grep and sed, unless we have specified to use the extended one. So this is I was talking about at the beginning, right? When I highlighted the Unix utilities, those utilities are grep and these are sed. So these utilities use BRE, that is the basic regular expression, until or unless you use a special flag to incorporate the ERE. BRE is generally more portable across different Unix-like systems. So BRE is a very portable thing across Unix-like systems. That means why we are saying Unix-like system. So today there are a lot of variants of the Linux. We have Red Hat, we have SUSE, we have Debian, we have Fedora, we have Ubuntu, and there are lots of many more Linux distributions. So these are we term as Unix-like system. That means today we have several number of branches and sub branches, and all of them supports the BRE. And you are writing any code, any regular expression syntax for the system utilities like grep or sed, that will be portable across these operating systems. first. Now here we have done discussion about the BRE. Let us move on to the next slide. Here we will talk about the extended or advanced regular expressions called ERE. ERE is an enhanced version of the regular expression syntax compared to the basic regular expression, that is BRE. This is an enhanced version and this is a superset of the BRE. That means whatever features you have in BRE, you have them in ERE, plus there are some more features. It offers a broader set of pattern matching capabilities. So that means we have more handyman tools for our work. ERE includes all the features of BRE and extended them with additional meta characters and constructs. So this is very technical thing and it's easy to understand. Let's move on to the next point. Common ERE meta characters include plus, pipe, set of brackets, that means first bracket, second bracket, and backslash. So these are meta characters from ERE. ERE supports alternation, grouping with parenthesis. Obviously, this grouping has to be done with parenthesis. Quantifiers for specifying repetition and more. So you can see the features in ERE are much more than the BRE, which we have talked about in the last slide. We have much more advanced features which are giving us more powerful handyman tools. Engineer our code. Meta characters in ERE do not need to be escaped with a backslash unless they are conflict with the literal characters. So here we can use a backslash n as a backslash n and they need not to be escaped unless you want to specify it as a string. That means this point we are exactly opposite to the BRE. ERE is widely used in shell utilities like awk, egrep, grep with e flag. So I was talking about until or unless we give a special flag. Here you can see we have a -e flag for the grep binary to use the ERE. That means if you are not using the -e, you are using the BRE syntaxes. Also in Perl, Python, Tcl, etc. the modern scripting language. That means ERE is adopted easily on all of these modern scripting languages. Using ERE can provide more flexibility and power in pattern matching compared to BRE. So that means we have a superset of tools and those we can use for our regular expression syntaxes, writing and matching. Here we are done discussing about extended or advanced regular expressions. Let us move on to the next slide. Now here come the crucial question. Python. After discussing BRE and ERE, you are wondering, okay, now Python by default uses which one? Either it is BRE or it is ERE. How should we know? Python's RE module supports both BRE and ERE. So that means we have support for both of them. By default, Python uses the ERE syntax for regular expression. That means you have to learn the ERE for Python programming, not the BRE. Here your concept is clear. So you have a complex regular expression you have seen somewhere using with grep or without the flag -e, right? And you want to port that into Python. That time you should be very careful because there it was using the BRE and here the Python is using ERE. So there will be a syntactical mismatch. You have to do the correct mapping or the correct change to implement the regular expression in Python. To use BRE syntax in Python, you can specify re.ascii or re.local flags when compiling the pattern. So that means these are two flags that can be used to access the BRE because by default Python is using ERE. The re.ascii or re.local flags indicate or force that the pattern should be interpreted as a basic regular expression, that is BRE. In Python, the focus is primarily on the regular expression syntax supported by the RE module. We have a module, RE module. So that module we are focusing primarily on the expressions supported by it. The RE module provides expanded features by default conform to ERE. That means these syntaxes are highly matching with the ERE. So you must be focusing on learning ERE. RegEx are used to define rules for matching strings such as sentences, email addresses, or log file error or warning messages. So this is very important because in VLSI, sometimes you have to read a log file and capture the error or warning message to find out the faults. It could be in front end, it could be in back end. Wherever you are parsing the log, your main scope of interest is on the error or warnings. That means the circuit is not behaving properly. Sometimes it could be due to a warning. Warning, it's not a error or it's not a fatal, right? I have not talked about fatal here. It could be error, warning or fatal. In case you have a fatal, that also has to be taken care, because something which is terminating the run of the simulation or something like that. So that has to be well taken care. And if it is a warning and it's not an error, that warning message might have some impact on the next error. That's why the error and warning both are important to be observed while you are doing the pattern matching and parsing a log file. Next, they allow you to check a string matches a pattern or if there is a match anywhere within the string. So it could be a partial matching or the whole matching. REs can also be used to modify strings or split them in different ways. So these are different set of operations with the strings for the automation and the parsing and the QC and the QA, whatever you are doing using our Python code. RegEx patterns are compiled by bytecodes and executed by a C-based engine. This is some technical information which happens behind. You don't have to learn it. You have to just have a proper overview of this point. That's all. Not all string processing tasks can be efficiently handled by regular expression. So this is another thing. If you think the regular expression is something that will give you all the solution, no. In some cases, you have to do something else to get your desired results. So this is a realistic overview of the regular expression. That means if you think that you have some magic tool with you and that magic is going to help you in every step, no, there could be some other ways of shooting the problem, and those might not be the regular expression. That might be something else. These things can be handled case by case basis and not in a generic manner. Hence, we cannot have a generic slide or generic information or generic set of bullets on them. So once you start working, this will be gathered within you from the working experience. We are done discussing about the Python basic engine for regular expression. Let us move on to the next slide. Regex matching, the range matching. From this slide, we will start diving into the Python's regular expression syntaxes. And first, we will talk about range matching. That means it could be a alphabet range or numeric range or alphanumeric range or something in between. Let us see what are there for us. Matching various sets of range characters is a key capability of the regular expression. Right now, first we have \d. This is a regular expression, right? We remove the quotes and use the \d in our regular expression. What it matches? You first know the rules before you can use them. So in this slide, we are teaching you the rules for range matching. Now \d matches any decimal digit equivalent to the class 0 to 9. That means we have a range of numerics from 0 to 9. It could be different combinations of 0 to 9. Okay. \D matches any non-digit characters equivalent to the caret then 0 to 9. Caret means not the 0 to 9. That means anything which is except any numeric combinations of 0 to 9. This will be matching. That means we have a positive match here and we have a negative match here for the decimal digits 0 to 9. \S matches any whitespace character equivalent to \T, N, V, all these things. Any whitespace character. And \S matches any non-whitespace character equivalent to the not of all of these. Now, again, we can see that this one is the not of this, as this was the not of this. That means we have a completely opposite set of matching. That means in the range matching. \W matches any alphanumeric character equivalent to this, that is A to small z, that means small a to small z, capital A to capital Z, and 0 to 9. So if any combinations of this, \W will match that. Next, if we use \W, it will match non-alphanumeric characters, and which is represented by this group where we have a negation. That means a not or the caret character followed up by small a to z, capital A to Z, and 0 to 9. Dot matches anything except a new line character, and there is a alternate mode re.all where it will match even a new line. So dot is often used when you want to match any character. So this is all the set of regular expression tools to match a range of characters or alphanumeric characters or any combinations of them. So let's move on to the next slide. Regular expression matching, micro matching. Here we will not match a range, rather we will do the micro matching, and here we will match exactly some of the characters or some of the numerals. Regular expressions allow specifying repeated micro positions of the pattern. So these are micro positions. The meta character star matches the previous character 0 or more times. That means we have A and then we have a star. That means we have 0 times A or more than 0 times A. For example, cat matches CT. Here you can see the star in between the cat, and this will match CT, the cat, and the CAAT. That means this A could be 0 times, 1 times, or many times. The meta character plus matches the previous character 1 or more times. Here you can see in star it was 0 or more times. That means there could be a no match situation. But here we want at least 1 or more than 1 matching. Plus will serve that purpose. For example, this one, that cat with a plus sign here, matches cat CAT but not CT. The question mark, that means this one matches something as optional, matching either once or 0 times. That means this many times is not possible, but either it is once or 0. That means either this case or this case will be served by the question mark. For example, home brew matches home brew or home dash brew. That means the dash followed up by question mark. The dash is absent here or present here. So that means whether it is absent or present, that is dealt with the question mark. The quantifier, this, that means within the curly brackets, right, we have m comma n, and these are syntaxes. These are not alphabets of m and n. So these have special meanings. Specify the minimum repetition of m number of repetition and maximum number of n number of repetition. That means this is a minimum and this is a maximum number of repetition. That means it could be 1, that means we have the cat, and it could be 3, that here could be 3. Right, that means we have this one. So we can use that for specific matching. That means you are restricting your match. For example, A then forward slash then 1/3 matches A slash B, A double slash B, and A triple slash B. That means we can match 1 time, which is this one. In between 1 and 3 there is 2, this is 2, and the last one we restricted to stop here 3, so it can match this. Omitting either m or n assumes reasonable default value. Omitting m sets the lower limit to 0, while omitting n allows the upper bound to infinity. That means if we do not give m, it means 0 to n, and if we do not give n, it means that we are starting from n, it can go up to the infinity. So these are the micro matching factors which you can use in regular expressions. We are done discussing this, so let's move on to the next slide. Thank you very much for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in words in the comment section down below, and bye for today.